if Z and Z bar represent the adjacent vertices of a regular polygon of n sides such that real part of Z upon imaginary part of Z is equal to square root of 2 plus 1, then n is equal to 4, 6, 8 or 16. These are the four options. Let Z equal to r e raised to power iota theta. Therefore, Z bar will be equal to r e raised to power minus iota theta. Now, it is given that Z and Z bar are the consecutive vertices of a regular polygon. Therefore, Z bar and Z are the rotation of the radius OZ bar by 2 pi by n. Therefore, Z can be equal to Z bar times e raised to power iota 2 pi by n. Or in other words, putting the values of Z and Z bar, r e raised to power iota theta is equal to r e raised to power minus iota theta into e raised to power iota 2 pi by n. That means e raised to power iota 2 theta is equal to e raised to power iota 2 pi by n. That means theta is equal to pi by n. But it is given that real part of Z upon imaginary part of Z is equal to root 2 plus 1. Therefore, real part of Z is equal to r cos theta, imaginary part of Z is equal to r sin theta. Their ratio is equal to cot theta. Therefore, cot theta is equal to root 2 plus 1, which is the value of cot of pi by 8. Therefore, theta is equal to pi by 8. But theta is equal to pi by n. Therefore, pi by n is equal to pi by 8 gives you n equal to 8. Therefore, it is an octagon whose number of sides are 8. The next question is, if 1 upon a plus omega plus 1 upon b plus omega plus 1 upon c plus omega plus 1 upon d plus omega is equal to 2 upon omega, where a, b, c, d belong to r, that means they are real numbers, then we have to find out the value of sigma 1 upon a square minus a plus 1. The options are 0, 1, 2 and 3. Now, given 1 upon a plus omega plus 1 upon b plus omega plus 1 upon c plus omega plus 1 upon d plus omega is equal to 2 upon omega. Taking conjugates of all the terms, we get an equality where we have 1 upon a plus omega square. Because a is a real number, the omega and omega squares are conjugate of each other. We get 1 upon a plus omega square plus 1 upon b plus omega square plus 1 upon c plus omega square plus 1 upon d plus omega square is equal to 2 upon omega square. Subtracting 1 and 2, we get summation of 1 upon a plus omega minus 1 upon a plus omega square is equal to 2 upon omega minus 2 upon omega square, which can be written as 2 times omega square minus 1. Simplifying left hand side, we get summation of omega square minus omega divided by a plus omega into a plus omega square is equal to 2 times omega square minus omega. Cancelling omega square minus omega on both the sides, we get summation of 1 upon a square minus a plus 1 equal to 2, because a plus omega into a plus omega square becomes a square minus a plus 1. Therefore, 1 upon a square minus a plus 1, summation of it is equal to 2. Therefore, option B is correct.